Bismillahirrahmanirrahim. Quote of the day: the future belongs to those who believe in the beauty of their dreams. Today, my topic of presentation is Spearman Correlation. I'll be presenting this topic under kind supervision of my professor, Dr. Saira Afzal. Learning outlines: history, introduction, advantages, disadvantages, the steps for calculating Spearman rank correlation coefficient, formula for computing the Spearman rank correlation coefficient, interpretations, examples, recent advances, MCQs. Learning outcomes. At the end of this presentation, participants will be able to define the Spearman rank correlation coefficient, its uses, steps for calculating, and the formula for computing the Spearman rank correlation coefficient. The Spearman correlation. Spearman's correlation is designed to measure the relationship between variables measured on the ordinal scale of measurement. Similar to Pearson's correlation, however, it uses rank as opposed to actual values. Introduction. Spearman's rank correlation coefficient or Spearman's rho is named after Charles Spearman, used Greek letter rho or as RS, non-parametric measure of statistical dependence between two variables. Assesses how well the relationship between two variables can be described using a monotonic function. Monotonic is a function or monotone function in mathematics that preserves the given order. If there are no repeated data values, so a perfect Spearman correlation of +1 or -1 occurs when each of the variables is a perfect monotone function of the other. Assumptions. The data is a bivariate random variable. The measurement scale is at least ordinal. Xi, yi is independent of xj, yj, where I is not equal to j. Advantages. Less sensitive to bias due to the effect of outliers, can be used to reduce the weight of outliers. Large distance get treated as one rank difference. Does not require assumptions of normality. When the intervals between data points are problematic, it is advisable to study the rankings rather than the actual values. Disadvantages. Calculations may become tedious. Additionally, ties are important and must be factored into the computation. The Spearman rank correlation coefficient. Rank correlation coefficient, the computations for the rank correlation coefficient are simpler than those for the Pearson coefficient and involve ranking each set of data. The difference in ranks is found and RS is computed by using these differences. If both sets of data have the same ranks, RS will be +1. If the sets of data are ranked in exactly the opposite way, RS will be -1. If there is no relationship between the rankings, RS will be near 0. Formula for computing the Spearman rank correlation coefficient. RS is equal to 1 minus 6 sum of d square divided by n square minus 1, where d is equal to difference in ranks, n is equal to number of data pairs. Steps for calculating Spearman rank correlation coefficient. Number one is convert the observed values to ranks, accounting for ties. Number two, find the difference between the ranks, square them and sum the square differences. Number three, set up hypothesis, carry out tests, and conclude based on findings. Steps for calculating Spearman rank correlation coefficient. If the null is rejected, then calculate the Spearman correlation coefficient to measure the strength of the relationship between the variables. Hypothesis 1, that is A two-tailed. In the null hypothesis, there is no correlation between the x's and the y's. There is mutual independence between the x's and the y's. In the alternate hypothesis, there is correlation between the x's and the y's. There is mutual dependence between the x's and y's. Hypothesis 2, one-tailed lawyer. Null hypothesis, there is no correlation between the x's and the y's. There is mutual independence between the x's and the y's. Alternate hypothesis, there is a negative correlation between the x's and the y's. Hypothesis 3, one-tailed upper. Null hypothesis, there is no correlation between the x's and the y's. There is mutual independence between the x's and the y's. Alternate hypothesis, there is a positive correlation between the x's and the y's. So here is the steps. Here are the steps for calculating Spearman rank correlation coefficient in a tabulated form. So the steps for finding and testing the Spearman rank correlation coefficient are given here in this procedural table. Number one is state the hypothesis. Number two is rank each data. Number three, subtract the rankings x1 minus x2. Number four, square the differences. Number five, find the sum of the squares. Number six, substitute in the formula where RS is the Spearman rank correlation coefficient, and D are the differences in the ranks, and N is the number of pairs of data. Step 7 is find the critical value. Step 8, make the decision. And step 9, summarize the results. So I would describe how to actually find out the Spearman rank correlation coefficient by some examples. Example number 1 is bank branches and deposits. A researcher wishes to see if there is a relationship between the number of branches a bank has and the total number of deposits in billion of dollars the bank receives. A sample of 8 regional banks is selected and the number of branches and the amount of deposits are shown in the table. At alpha is equal to 0.05, is there a significant linear correlation between the number of branches and the amount of deposits? About the deposits. So here's data given, number of bank and the number of branches and deposits in billions. So the solution of this would be, first we have to state the hypothesis, null hypothesis rho is equal to 0, alternate hypothesis rho is not equal to 0. Find the critical value, and for n is equal to 8 and a is equal to 0.05, it would be 0.738. Find the test value. So first of all, we have to rank each data set as shown in the table. So we have to rank it, that is like the branches and the deposits, we have to rank this data. So I would further describe as well how to rank the data. So then after ranking the data, number B is let X be the rank of the branches and X2 be the rank of the deposits. Let subtract the rankings and then square the differences and then find the sum of the squares. The result can be summarized in a table as shown. So here we can see that X1, X2 are the rankings and D is basically the difference of X1 minus X2, and D square, we have to find the D square of this D. So then after that, we have to find the sum of the D square, which is 12. And then we have to find this, we have to substitute all this data in the formula for the Spearman rank correlation coefficient, which is 1 minus 6 sigma d square divided by n into n square minus 1, and n is the number of pairs here. The answer would be 0.657. So step 4, we have to make the decision, do not reject the null hypothesis since RS is equal to 0.657, which is less than the critical value of 0.738. So we have step 5, we have to summarize the results. There is no enough evidence to say that there is a linear relationship between the number of branches a bank has and the deposits of the bank. Example number 2. So the Spearman's rank correlation coefficient is used to discover the strength of a link between the two sets of data. So in this example, looks at the strength of the link between the price of a convenience item, a 50 cl bottle of water, and distance from the contemporary art museum. We have shown this data in a scatter diagram here in this graph. You can see this, the price of convenience item and shops along transact with distance from the contemporary art museum. So now the method of calculating the coefficient, we have to, first of all, after the data, we have to create a table from your data. Then number 2, rank the two data sets. Ranking is achieved by giving the ranking 1 to the biggest number in a column and 2 to the second biggest value, and so on. The smallest value in the column will get the lowest ranking. So that's how we do the ranking. We give the highest value to the highest number. Okay. The number 1 ranking is given to the biggest number. So and so on, we keep on going to the second one. This should be done for both sets of measurements. Tide scores are given the mean, that is the average rank. For example, the 3 tide scores of €1 in the example below are ranked 5th in order of price, but occupy 3 positions, 5th, 6th, and 7th in a ranking hierarchy of 10. The mean rank is, in this case, is calculated as 5 plus 6 plus 7 divided by 3 is equal to 6. Find the difference in the rank, that is D. This is the difference between the ranks of the two values on each row of the table. The rank of the second value, price, is subtracted from the rank of the first distance from the museum. Square the differences to remove negative values and then sum the D square. So I can show you that here is a table that we have actually made from the data. So as I have described earlier, you can see that the total number of the n is equal to 10. So distance from the contemporary art museum and the price of the 50 cl bottle, they both are given. So we have to rank them up. So we have ranked them as I have already described. We have to give the highest rank to the first rank to the highest value. So you can see in this table as well. So you can see that 980 is the value that is like the highest value. So we gave it the first rank. So now put all these values in the formula. So after finding the ranks, we have to find out the difference, and this is the D, and then you square them up, and then this is the D square. Now further, put all these values into the formula, find the value of all the D square values by adding up all the values in the difference column in the D square column, difference 2 column. In our example, this is 285.5. Multiplying this by 6 gives 1713. Now for the bottom line of the equation, the value n is the number of sites at which you took measurements. This is in our example is 10. Substitute these values into n3 minus n, we get 1000 minus 10. We now have the formula Rs is equal to 1 minus 1713 divided by 990, which gives a value of Rs. That is 1 minus 1.73 is equal to minus 0.73. So here, after finding this d square, we actually we have to compute all the values in the formula that I've already described. And then after this, you get this answer of minus 0.73. So what does this R value mean? The closer R is to positive 1 or minus 1, the stronger the likely correlation. Perfect positive correlation is positive 1, perfect negative correlation is minus 1. What is it showing? So here this is also represented in the form of a graph as well. You can see that R is close to 1, which means that if there's like you go from 0 to positive 1, there will be positive correlation. You go from 0 to minus 1, there will be negative correlation. In this graph, there's total agreement. Overall, neither agree or disagree, and then total disagreement in this graph. So a correlation coefficient is basically a numerical measure or index of the amount of association between two sets of scores. It ranges in size from a maximum of positive 1 through 0 to minus 1. The positive sign indicates a positive correlation. The scores on one variable increases as the scores on the other variable increases. The sign indicates a negative correlation. On one variable increases, the scores on the other variable decreases. Interpretation. The sign of the Spearman correlation indicates the direction of association between X, the independent, and Y, the dependent variable. If Y tends to increase, when X increases, the Spearman correlation coefficient is positive. If Y tends to decrease, is there any issue? Can everyone hear me?
Yes, you are audible.
Okay. The sign of Spearman correlation indicates the direction of association between X, the independent variable, and Y, the dependent variable. If Y tends to increase when X increases, the Spearman correlation coefficient is positive. If Y tends to decrease when X increases, the Spearman correlation coefficient is negative. A Spearman correlation of 0 indicates that there is no tendency for Y to either increase or decrease when X increases. Alternative name for the Spearman rank correlation is the grade correlation. The rank of an observation is replaced by the grade. When X and Y are perfectly monotonically related, the Spearman correlation coefficient becomes 1. A perfect monotone increasing relationship implies that for any two pairs of data values, xi, yi, and xj, yj, that xi minus xj and yi minus yj always have the same sign. Recent advances. Sequential estimation of Spearman rank correlation using Hermite series estimators. Abstract. In this article, we describe a new Hermite series based sequential estimator for the Spearman rank correlation coefficient, provide algorithms applicable in both the stationary and non-stationary settings. To treat the non-stationary setting, we introduce a novel exponentially weighted estimator for the Spearman rank correlation, which allows the local non-parametric correlation of bivariate data stream to be tracked. To the best of our knowledge, this is the first algorithm to be proposed for estimating a time-varying Spearman rank correlation that does not rely on moving a window approach. We explore the practical effectiveness of Hermite series-based estimators through real data and simulation studies, demonstrating good practical performance. The stimulation studies in particular reveal competitive performance compared to an existing algorithm. The potential applications of this work are manifold. The Hermite series-based Spearman rank correlation estimator can be applied to fast and robust online calculation of correlation, which may vary over time. Possible machine learning applications include, amongst others, fast feature selection, hierarchical clustering on massive data sets. Effects of COVID-19 pandemic on the online learning behavior of university students in Taiwan. Abstract. Prior to the coronavirus disease, 2019 COVID-19 pandemic, due to the rarity of pandemics in recent centuries, suitable conditions did not exist in educational institutions for the implementation of asynchronous distance teaching. No empirical studies have been conducted on whether the considerable environment changes caused by COVID-19 to have affected students' online learning behaviors. Therefore, this study collected information on students' online learning behavior during the COVID-19 pandemic and other periods to examine whether pandemic caused environmental changes affected students' online learning behaviors. This study focuses on the 60-day transmission after the beginning of the second semester of 2019 academic year. The data source was from a comparative assessment between the pandemic group 331 students and the control group 101 students. The Spearman rank correlation test and the Wilcoxon signed rank test were used as our statistical methods. This paper presents preliminary results on how COVID-19 has affected students, online learning behaviors, and proposes asynchronous online learning as the method for maintaining university students' learning during the COVID-19 pandemic. Time for MCQs. MCQ number 1. A composite rating is given by executive to each college graduate joining a plastic manufacturing firm. The executive ratings represent the future potential of the college graduate. The graduates then enter an in-plant training program and are given another composite rating. To determine rank correlation coefficient, if null is rejected, the formula used is A, B, C, D, E. There are certain formulas given. So which one would be the formula used for finding Spearman rank correlation coefficient?
A.
C.
So yeah, that would be C. The answer is C. Here, you can see as well, I already described the formula used as this: rho is equal to 1 minus 6 sigma of d square and divide n into n multiply to n square minus 1. Number 2, if 6 handwritings were ranked by 2 judges in a competition and the rankings are as follows, then determine the Spearman's rank correlation coefficient. A minus 1, B 0.5, C 0.5, D 1, E 0.05. So we have to do some calculation in this MCQ. I have given the data in the form of, the data is given in the form of a table and it is ranked already. Yeah, that is A minus 1. Here is the calculation as well. You can see the Spearman rank correlation coefficient. The formula is here. The ranking is done. We have to simply, as I described, we have to simply we have to do the, after ranking, we have to find the D, which is you have to minus R1 from R1 minus R2. That is here in this column. And then you have to find the square of the difference. That is here. Then the sum of the difference, and then you compute it in the formula and get the answer. That is minus 1. MCQ number 3. If the sum of the square of difference of ranks of 6 candidates in 2 criteria is 21, the rank correlation coefficient is A 1 minus 5, B 0.6, C 0.4, D 0.7, E 0.2.
A.
No. It's the answer would be C. I would tell you how. You can see here in this calculation as well. Again, I have given you the formula. This is the formula here. So here we have already, they told us that the difference of the ranks of 6 candidates is 21, right? So here the difference is already given. So what we have to do is we compute the whole value in this formula. And then after computing, we find the value would be 0.4. MCQ number 4. The given table shows the ranking of 10 students in statistics and mathematics. The coefficient of rank correlation is here. The ranking is done and we have to find the coefficient of the rank correlation. So the answer would be A 0.03, B minus 0.3, C 0.1, D minus 0.1, E 0.05. Here is the calculation as well. So see, again, the formula used would be this, and then the ranking is done, you find out the difference, and then you sum them up, and the answer would be minus 0.3. MCQ number 5. In Spearman rank correlation coefficient, R is equal to 1 minus 6 sigma d square n in n times n square minus 1. The maximum value of sigma d square in case of untied rank is A 1 by 2 or half n square minus 1, B 1/4 n square minus 1, C n, D 1 by 3rd n times n square minus 1, E n minus 1.
A.
No, it would be D.
E.
No, it would be D. Let me show you how. Here's the solution as well. As I've told you, this is the formula. So if you do simple maths in this, you can understand that the maximum value of sigma d square in case of untied rank is 1 by 3 n square minus 1. MCQ number 6. A researcher used the Spearman rank correlation coefficient to see if there is a linear relationship between these two sets of data. representing the number of calories and the amount of cholesterol in fast food sandwiches. So table 1 is showing the data. The Spearman rank correlation test requires that the A, data must be measured on the same scale. B, data should not be of ordinal scale. C, data must be distributed at least approximately as a T distribution. D, data must not data must be from the two independent sample. And E, data should be of ordinal scale. Anyone?
D.
C.
No. No, the answer would be E in this. MCQ number 7. The Spearman's rank correlation coefficient for the year 10 maths and English scores is 0.81. Which of the following is true? A, there is a strong negative correlation. B, there is a weak negative correlation. C, there is a strong positive correlation. D, there is no such correlation. E, there is weak positive correlation.
A.
No, it would be C, as it is 0.81. So there would be strong positive correlation because it's going to it's around about 1, because as you go near to 1, it would be more positive. Write down the value, MCQ number 8, write down the value of the Spearman's rank correlation coefficient for the set of data. A, 0.1, B, 1, C, -1, D, 0, E, 0.01. It's Charlie -1. No, it's Charlie -1. MCQ number 9. The ICC rankings for one-day international and test matches for 9 teams are shown below. The correlation coefficient between the rank is A 0.66, B 1.6, C 0.833, D 1, E 0.44. The answer would be Charlie 0.833. You have to again use the same formula, and after computing the values, you would get the answer 0.833. MCQ number 10. 8 dances are performed at a local dance competition. After seeing all the dances, 2 judges rank the dance in orders. So the dance each judge likes best has rank 1. So here is the data given as well. From this data, what does the Spearman's rank correlation coefficient tells us? Number A, how strong the correlation between the data is. Number B, how strong an upward or downward trend the data has. C, if the correlation between our variables is linear or nonlinear. D, a line of best fit for the data. E, if data does not give any significant information about any correlation between the data.
A.
No, it would be B. How strong an upward or downward trend the data has. Here's the key. And there are the references as well. And here is the YouTube link as well. Kindly subscribe and like. Thank you so much, everyone, for the time.